Hi, I'm Simon Ho. I'm a PhD student from ANU and Swinburne. So today I want to tell you the story of Simon and the giant pulse. So this is a study of giant pulses and trying to compare them with the M81 FRBs. In this work, I'm working with Matthew, Chris, and Federico. So once upon a time, there were FRBs detected by CHIME that was localized in a global cluster. So before that, astronomers, most of them thought that the progenitor of FRBs are magnetars, perhaps. However, we know that magnetars and global clusters are quite different. Magnetars, they are young populations, but global clusters, they are full stellar populations. So in this study, we're trying to see if the M80 FRBs are actually extragalactic giant pulses. So this is our target. J1823-3021A. It is, in fact, the most active giant pulse emitting millisecond pulsar in a global cluster. So here I summarize the specifications and the results of previous studies and our work. There are two main things here. So in short, we have meerkats, we have better sensitivity, and we have better time resolution. Also, UHF is good because there's less RFI in meerkats, and pulses are brighter in the lower frequencies. Therefore, we have more detection. We have about 37,000 giant pulses in an hour, which is a lot. This is the brightest giant pulse we have found with a signal-to-noise ratio of 253. However, this is not quite bright enough to consider as extragalactic yet. We found some similarities with FRBs. For example, we found giant pulses with multi-components. And these are actually commonly seen in some FREs. We also found a possibly quasi-periodic giant pulse, which in this case, the CHIME team also found a quasi-periodic giant pulse, FRB. So they are kind of similar, I would say. In contrast, we also found differences between giant pulses to the FRBs. For example, giant pulses, they are really periodic, so they show significant periodicity. Also, in this case, the giant pulses are not really polarized. Compared to FRBs, they are really polarized. In this case, this FRB shows 100% linear polarization. So here are the take-home messages. We have detected over 37,000 giant pulses in an hour, which is 13 times higher than the previous study. We found similarities like multi-peak structures and quasi-periodicity. We also found differences like they are not polarized and significant periodic. In the future, we are trying to coherently descatter the giant pulses to compare their real pulse shape with FRBs. Thank you.